Hi, in this lecture we are gonna study the drivetrain. The drivetrain is made up of all components that transfer power from the engine to the driving wheels of the vehicle. The exact components used in a vehicle's drivetrain depends on whether the vehicle is equipped with a rear-wheel drive or a front-wheel drive or four-wheel drive. Today, most cars are front-wheel drive. Some larger luxury and performance cars are rear-wheel drive. Most pickup trucks, minivans, and SUVs are also rear-wheel drive vehicles. Power flow in a rear-wheel drive vehicles passes through the clutch or torque converter, manual or automatic transmission, and the drive line. Then it goes through the rear differential and the rear driving axles and into the rear wheels. Power flow through the drivetrain or front-wheel drive vehicles passes through the clutch or torque converter, then moves through a front differential, the driving axle, and into the front wheels. The four-wheel drive or all-wheel drive vehicles combine features of both rear and front-wheel drive systems so that power can be delivered to all wheels either on a permanent or on-demand basis. Typically, if a truck pickup or SUV has a four-wheel drive, the system is based on a rear-wheel drive and a front drive axle is added. When a car has all-wheel drive or four-wheel drive, the drivetrain is a modified front-wheel drive system. A modification includes a rear drive axle and an assembly that transfers some of the power to the rear axle. We'll start with the first component, which is the clutch. Clutch is used with a manual transmissions and transaxles. It mechanically connects the engine's flywheel to the transmission or transaxle input shaft. This is accomplished by a special friction plate that is splinted to the input shaft of the transmission. When the clutch is engaged, the friction plate contacts the flywheel and transfers power to the input shaft. When stopping, starting, and shifting from one gear to the next, the clutch is disengaged by pushing down on the clutch pedal. This moves the clutch plate away from the flywheel, stopping power flow to the transmission, and the driver can then shift gears without damaging the transmission or transaxle. Releasing the clutch pedal, re-engage the clutch and allows power to flow from the engine to the transmission. And let's move to the manual transmission. A manual or standard transmission is one in which the driver manually selects the gear of choice. Proper gear selection allows for good drivability and requires some driver education. Whenever two or three gears have their teeth meshed together, a gear set is formed. The movement of one gear in the set will cause the others to move. If any of the gears in the set are different size than the others, the gears will move at different speed. The size ratio of the gear set is called the gear ratio of that gear set. A manual transmission houses a number of individual gear sets, which produce different gear ratios. The driver selects the desired operating gear or gear ratio. A typical manual transmission has 4 or 5 forward gear ratios in neutral and reverse. Also, we have the automatic transmission. An automatic transmission doesn't need a clutch pedal and shift through the forward gears. Without the control of the driver, instead of a clutch, it uses a torque converter to transfer power from the engine's flywheel to the transmission input shaft. The torque converter allows for a smooth transfer of power at all engine speeds. Shifting in an automatic transmission is controlled by a hydraulic or electronic control system. In a hydraulic system, a network of valves and other components use hydraulic pressure to control the operation of planetary gear sets. These gear sets provide the 3 or 4 forward speeds, neutral, park, and reverse gears, normally found in an automatic transmissions. Newer electronic shifting systems use electric solenoids to control shifting mechanisms. Electronic shifting is precise and can be varied to suit certain operating conditions. All automatic transmission-equipped vehicles with OBD2 have electronic shifting. Also, another part that we have is the drive line. Drive lines are used in rear-wheel drive vehicles and four-wheel drive vehicles. They connect the output shaft of the transmission to the gearing in the rear axle housing. They are also used to connect the output shaft to the front and rear axle drive on a four-wheel drive vehicle. A drive line consists of a hollow drive or a propeller shaft that is connected to the transmission and the drive axle differential by universal joint or U-joints. These U-joints allow the drive shaft to move with a movement of the rear suspension, preventing damage to the shaft. Also, another part that we have is the differential. On a rear-wheel drive vehicles, the drive shaft turns perpendicular to the forward motion of the vehicle. The differential gearing in the rear axle housing is designed to turn the direction of the power so that it can be used to drive the wheels of the vehicle. The power flows into the differential, where it changes direction, then it flows to the rear axles and wheels. The gearing in the differential also multiplies the torque it receives from the drive shaft by providing a final gear reduction. Also, it divides the torque between the left and right driving axles and wheels, so the differential wheel speed is possible. This means one wheel can turn faster than the other when going around turns. Also, we have the driving axles. Driving axles are solid steel shafts that transfer the torque from the differential to the driving wheels. A separate axle shaft is used for each driving wheel in a rear-wheel drive vehicle. The driving axles are part of the differential and are enclosed in an axle housing that protects and supports these parts. Some rear drive axle units are mounted to an independent suspension, and the drive axle assembly is similar to that of a front-wheel drive vehicle. Each drive axle is connected to the side gears and the differential. The inner ends of the axle are splinted to fit into the side gears. As the side gears are turned, the axle to which they are splinted turn at the same speed. The drive wheels are attached to the outer ends of the axle. The outer end of each axle has a flange mounted to it. A flange is a rim for attaching one part to another part. The flange, fitted with studs at the end of an axle, holds the wheel in place. Studs are threaded shafts resembling bolts without heads. One end of the stud is screwed or pressed into the flange. The wheel fits over the studs, and nut, called the lug nut, is tightened over the open end of the stud. This holds the wheel in place. The differential carrier supports the inner end of each axle. A bearing inside the axle housing supports the outer end of the axle shaft. This bearing, called the axle bearings, allows the axle to rotate smoothly inside the axle housing. Also, we have the transaxle. A transaxle is used in a front-wheel drive vehicles. It's made up of a transmission and differential housed in a single unit. The gear set in the transaxle provides the required gear ratios and directs the power flow into the differential. The differential gearing provides the final gear reduction and splits the power flow between the left and right drive axles. The drive axles extend from the sides of the transaxles. The outer ends of the axles are fitted to the hubs of the drive wheels. Constant velocity or CV joints mounted on each end of the drive axles allows for changes in length and angle without affecting the power flow to the wheels. Also, we have the four-wheel drive system. A four-wheel drive system or all-wheel drive vehicles combine the features of a rear-wheel drive transmissions and front-wheel drive transaxles. Additional transfer case gearing splits the power flow between a differential driving the front wheels and a rear differential that drives the rear wheels. This transfer case can be a housing bolted directly to the transmission, or it can be a separate housing mounted somewhere in the drive line. Most rear-wheel drive-based four-wheel drive vehicles have a drive shaft connecting the output of the transmission to the rear axle and another connecting the output of the transfer case to the front drive axle. Typically, all-wheel drive cars have a center differential which splits the torque between the front and rear drive axles.